welcome to the 10 a.m. class. These are some of the problems that we covered, not the actual problem, but a new problem. So write these down. Go ahead and push pause and try them out. You should be able to do each one of these, and then I will show you how to do them. Okay, go ahead. All right, when we look at this problem, the first thing you should do, the first thing that should come to your mind is to put a 1 under that 3. Now, you have numbers in the numerator, 1 times 3, which just gives you 3. And you have numbers in the denominator, 11 times 1, which is 11. We should look at our answer and make sure that it doesn't need to be simplified, but 3 is a prime number and 11 is a prime number, so there's nothing that will go into those both. So this problem is done. Okay? Well, in this next one, again, the first thing that you should do, the first thing that should jump out at you is put a 1 under that 3. Okay? Now, we have two fractions, but do we like to divide by fractions? No. What we do instead is we multiply by the reciprocal of whoever's doing the dividing. Since 1/4, 3 is divided by 1/4. 1/4 is doing the dividing. So that is the number that we're going to take the flip of, the reciprocal. So the reciprocal of 1/4 is 4 over 1. Our other number is still the 3 over 1. Okay, so that's our new problem, which is exactly like this problem. 3 times 4 in your numerator gives you 12. In your denominator, we have 1 times 1, which is just 1, and that really means 12 because 1 is understood. It's not really needed. Okay? All right, in the next problem, if you look at this, you might notice that there are some numbers that they share, for lack of better words. Let me show you how to write it all out, but you can do it a lot quicker if you know how, and that's fine. Go ahead. All right, so 3 is a prime number. Prime number just means it's 1 times itself. So 3, there's nothing else we can do to that. Times 5 is a prime number. Again, there's nothing else I can do to that 5. So I'm just going to keep it there. Now, I know that 10 is 1 times 10, but it is also 2 times 5. That 5 goes with this one. Because it has a number that they agree on, I want to use that combination for my 10. So this, 2 times 5, is in place of that 10. Okay? 6 is 1 times 6, but it is also 2 times 3. And there's a 3 in both of those. So that would help me. So I'm going to put 2 times 3. Okay? So the 2 times 5 replace the 10. The 2 times 3 replace the 6. Now, you might be able to just cross it out right here in this part of the problem, and that is fine if you feel comfortable doing that. If not, this is completely written out, okay, just so that I could show you what we're doing. All right, now, 5 and the 5, what's 5 divided by 5? Well, it's 1. That means it cancels out and leaves us just with a 1. Okay? 3 divided by 3 is also 1. So it cancels out. That leaves us with a numerator of 1 times 1, which is 1, and a denominator of 2 times 2, which is just 4. Okay? That would be your answer. Now, if you have gone through and done 3 times 5 is 15, and 10 times 6 is 60, okay, that answer is correct, but you need to reduce that. This is what you're really doing, but you could have also said, well, I'm going to divide both the top and the bottom by 15, which gives us the 1/4. okay? That's how you've previously done that. But what we want to do is aim towards this thought because, and let me show you a problem where that would help us. So this is what you've done in elementary math, middle school math. How does that translate into algebra and higher math? Okay, we are going to look at this problem, 3x y to the fourth all over 4x squared y squared. Okay? So, what do? Well, let's take a look. First of all, 3 is a prime number, so I don't need to worry about that at all. Okay? X, there's just one x right there. So I'm going to just put that I'm multiplying it and there's an x there. Now, this says y to the fourth. That means I have 4 yaks, or 4 y's. So let me write that out. 1, 2, 3, 4. Okay? Just like we know 2 to the fourth means 2 times 2 times 2 times 2, y to the fourth means y times y times y times y. Okay? Down here, now we have a 4. Now 4 is not a prime, it is a composite number. This is 1 times 4 and 2 times 2. They are the factors of 4. But none of these numbers match the 3. So that's not going to help us by breaking it down any farther. So we're just going to keep the 4. Now, x squared means x times x. So we're going to write that out. And y squared means y times y. Okay? Now, using the same idea as we did up here, I know that x divided by x, just like 3 divided by 3, is actually just 1. Okay? I also know that y divided by y is 1, and here's another y divided by 1, which is just 1. That leaves us with an answer of 3y times y. So if we have a y times y, that means we have a y squared. And in the denominator, we have a 4 and an x. That is actually the answer to this problem. That is why if we can begin to look at the fractions in that idea, when you get to it in algebra, you'll understand what to do. Okay? So we've been working on these 2 types of problems. We've done a few of these. We just need a little bit more practice, but we should know how to do them. Okay? The next thing we took a look at was still dealing with fractions, but we're going to look at these problems. 8/9 minus 1/9 and 1/2 plus 1/3. Okay, so go ahead and hit pause and go ahead and answer those. You should be able to do those, I believe. Okay, and we'll look at our answers in just a minute. We see that we have common denominators. When we were working with multiplication and division, we did not need common denominators. But when you work with addition or subtraction, you must have a common denominator, the bottom number. Okay? This one has the 9. It is common. So what we do is the answer still has that 9 in the denominator. It just carries right through. Now, we have 8 minus 1, which we know is 7. Now, we should check this and see if we need to simplify, but 7 is a prime number. 9 and 7 don't agree on anything, so we're done. Okay, so you should have been able to get that answer. Now, when I look at the next problem, I notice that even though my numerators are common, I do not have a common denominator. So I need to make these numbers the same. What you're really doing is you're counting by twos, 2, 4, 6, 8, 10. And you're counting by threes, 3, 6, 9, 12, 15. But I noticed they agree on 6, which means my common denominator is actually going to be 6. That's what they agree on. Okay. Now, what we need to do is figure out 2 times what gave us 6? Well, we know that 2 times 3 gives us 6. So whatever we do in the bottom, we also must do on the top. So 1 times 3 gives us 3. Okay? The next one, 3 times what gives us 6? Well, we know 3 times 2 gives us 6, which means we also need to do that to the top number. So 1 times 2, we know, is 2. Now we have a new problem. These fractions are equivalent, but we have the common denominator. Because we have a common denominator and we are adding, we can now go and get the answer. So the answer keeps that common denominator, and we add 3 plus 2, which is 5. And that problem is done. And again, we cannot reduce this because 5 is prime, 6 doesn't have anything that agrees with the 5, so it is done. Okay? Now, one of the things that kept coming up in the homework problems that you gave me were a little bit of confusion of place values. So what I want to do is let's take 7/9, and we're actually going to come up with the decimal. We've done this before back when we were talking about 1/4 of the pizza or 2/7 of the pizza. Okay, so that was back when we first started our spring semester. But I think some of you have forgotten. So let's take a look at this. We know this says 7/9, or this really means 7 divided by 9. Okay? To find our decimal, we need to know that fact so that we can set up a division problem. This says 7 is being divided by the 9. That means 7 is being divided by the 9. Okay? Now, does 9 go into 7? No. Okay? So we're going to put a 0. We add a decimal and another 0. We bring that decimal up. Okay? Now, does 9 go into 70? And yes, it does. It goes in 7 times. 9 times 7, so that was our division step. Now we're going to multiply. 9 times 7 is 63. Now we're going to subtract. 70 minus 63 is 7. Okay. We compare. Is 7 less than 9? Yes, it is. Now, because this is a decimal, we actually need to keep going. You cannot write 0.7 remainder 7. What you have to do is add another 0 and bring that down. If you notice though, it's 70 again. 9 goes into 70, we already know that, 7 times. That again gives us 63. That again gives us a remainder of 7, okay? Does anyone remember what a fraction, a decimal is called when it continues to repeat? We talked about that, I believe, the first day of our spring semester, okay? If your fraction or decimal does not come to a stop, it is actually an irrational number. So this is irrational. It is one of those fractions or decimals that does not stop. And to show that it is irrational or it continues, we put a bar over the 7 to show that that 7 continues to repeat. Okay? All right, so this number is irrational. Okay, now what was really coming up on that homework was the place values. There was a little bit of confusion there. So I had this big, long, huge number that I wanted to go over what each place is called. Okay? This is the ones place. Tens, hundreds. And then it basically just repeats. So this is 1,000. Okay, then 10,000. And then 100,000. Then we move into millions. So this is 1 million, 10 million, 100 million. So actually 100 million. These are getting a little bit long to write. And then we move into 1 billion. And again, it would be 10 billion, 100 billion, okay? You've all had that. Some books do not emphasize this, but you really should know this is the ones, thousands, millions, billions. You really should know that, okay? It doesn't come up a lot, but you should be able to answer this. Now, this is where we got a little bit of confusion was with the decimal. When you have the decimal, you actually say and. Okay, when you read this problem, read this answer, this would be and. Now, the spot that is here is not actually the ones, it is the 10, whoops, the 10 and put a th on the end, a THS. Okay, so the first spot is the tenths. The next spot is the hundredths. And then we have the thousandths. And again, the THS. Okay, so there was some confusion on those problems in that worksheet. That was one of the things that a lot of you had wrong. Now, this answer is 0.7, and that 7 keeps going, right? Doesn't stop. If I asked you to give me this answer in tenths, that means we would have that point. It would be 7, but we need to look to see if it were going to round. So when we want tenths, that's that spot, we look at the next number, and since that is above a 5, or at 5, you hear bells going off, ding, 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 ding. If it's above 5, you are going to round up, which means this number is no longer 7, we're going to round that to 8. And everything behind it gets wiped away. That's if you're doing tenths. Okay. If you wanted this in hundredths, that would give us, looking at this spot. So again, we would look at the next number. Ding, 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 ding. It's above 5, we are going to round. So this number is 0.7, and then round the hundredth spot to the 8, and everything is cut off from there. Okay. If we wanted the thousandths, that is this spot. Again, we always look at the next number to see if we should round up or down. It is ding, 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 ding. It's more than 5. It's 5 and above. So we're going to round this number up. So we keep the first 2. There's the first 7. There's the second 7. But now this one would round up and everything else would be wiped away. Okay, so there was a little bit of confusion about that. I know you've had it. I just don't think many have practiced that. So make sure you take a look at that. Alrighty. Now, the next thing we moved into was some equations and graphing. So let me go ahead and clear this off. You can go ahead and finish copying that down if you need to. Actually, you should copy that down because you really need to. So if you were to read this number, this would be 6,392,471,503 and 257,000. And that's a hard one to say. Okay, so just so you know. All right, let's take a look at this problem. 2x plus 2y equals 8. Okay? Now, the directions say graph. Okay, so we are going to look at two different things here. We are going to look at solving this equation so that we can graph it and getting it on our graph. Okay, so go ahead and copy that down. If you feel comfortable with it, go ahead and work on it. Okay, so in this problem, when we are graphing, we always are working towards y equals mx plus b. Now, that's later on in algebra. It's actually the main concept of algebra. But if we begin to learn the words, when we get there, it will really be second nature. So we're always solving for y equals mx plus b, that form. This form is known as slope intercept. And we've talked about that before. I've mentioned these words before, but we're going to continue to mention them. Okay, now, that means we have to solve for y. That means everything else has to cross over that wall. Okay? So the first thing we would do is we would send those aunts and uncles home. Family, but they need to go to their own house. In this example, it's not just a 2, it's the whole 2x, but we do it the same exact way. So we're going to move the 2x to the other side. To move something to the other side, what do? We add the opposite. What is the opposite of that positive 2x, which is a plus 2x? That would be a minus 2x to both sides. Okay? Now, those 2x's cancel out. We're left with 2y equals 8 minus 2x. Are those like terms? Hopefully you're saying no. They are different. 8 minus 2 x-ray fish. They don't go together. Okay? So that's 8 minus 2x. But I noticed that my form is y equals the x term and then something else. So what I'm actually going to do is I'm just going to switch these around. Because of the commutative property of addition, I can commute these. I can move them around. The only thing I have to be careful of is that 2x must keep the negative, and the 8 is positive, so I'm just going to go positive 8. This means exactly the same thing, except I used the commutative property, which you've had in foundations. Weeks 20-ish, whatever, somewhere in there. Okay? Now, we still want y alone, but this is mom and dad. This is a little bit hard to separate, okay? This says 2 times y, so we're going to do the opposite, which is division. So we're going to divide every piece by that 2. I like to do it under each one so that I do not forget. The 2's cancel out. We're left with y equals negative 2 divided by 2 is 1, and we've not done anything with that negative, so it still remains negative 1x, plus 8 divided by 2, which is 4. Now remember, that 1 is actually the understood one, just like in our English, so we don't need it there. Okay, you could have it there, but you really don't need it. All right, now we notice it looks very similar. Okay. For our purposes, we've been doing a table where y actually equals the negative x plus 4. Okay. You might remember, or hopefully you remember, that x is our input. We get to put values in for x, and out comes an answer. So our y is our output. Okay. Who remembers the x that we always put in first? You should have said 0. So let me put a 0 in here. Now, that says when I put a 0 in for x, I have negative 0, which is just 0, plus 4. What is my answer? Well, it's 4. That tells me my ordered pair is 0, 4. Okay? So when we put that on our graph, that means x in the x direction is 0, so it's right here at the origin. My y value is 4. That means we are going to go positive 4. 1, 2, 3, 4. So that point is right there. Notice that point and that number are the same, aren't they? If you notice in our form, this is actually b, which is your y-intercept. It is always the first point you put on your graph, whether you use a table or whether you learn to do it by your intercept. Any number that is here after the plus sign is your b, which is known as your y-intercept, which means it intercepts, it crosses over the y-axis. Okay? So let's try another number. 2 points make a line, so we have to do at least one more. Now, you can pick any number you want. So push pause and do 2 more numbers and graph them. And then you can come back and check. Okay, I'm going to choose one just because I like it. That gives me negative 1 plus 4. Now be careful. That says you owe mom $1, and then you got $4 for allowance. How much do you have in your pocket now? You actually have 3. So your ordered pair is 1, 3. Okay? So you come over here to your graph. That says when my x is 1, my y is 1, 2, 3, which goes right there. Okay, so that's pretty close. 2 points make a line, but 3 points make sure we did it correctly. So let's try another point. Let's try negative 2, okay? So this says negative 2 plus 4. Well, negative times a negative is that magnetic effect, which turns it into a positive. So this is actually a positive 2 plus 4, which gives us 6. Our ordered pair is negative 2, 6. Okay, so let's find it on our graph. And you could have different points, no big deal. So when x is negative 2, our y is 6. 1, 2, 3, 4, 5, 6. Maybe right about there. Okay. Now, we are going to connect those points. Okay. If you use graph paper, it'll be a little bit easier to get a straight line, but it works. Make sure you put arrows on there because it is a line, and a line is indefinite. It does not stop. Okay? Now, is this line going uphill or is it going downhill? Okay? It is actually going downhill. Because it is going downhill, is this a positive slope or a negative slope? Down usually means going towards the negative, so this is actually a negative slope. And our slope is actually this M. Okay? In this problem, it's actually negative, and again, remember there is a 1 in there. So your slope is actually -1, whatever number is in front of that x. Okay? And so you have graphed this equation, which came from here. All right. So you have a homework due on July 10th, which is our next lesson. It is loaded on the Facebook page, so if you were not able to join us yesterday, you can go ahead and grab it. For those of you that were not here yesterday, you'll have 2 papers to hand in. Make sure you watch this video and that you try these problems, and have a great 4th of July, and I will see you when we're all back together again. Thanks.